Okay, question 2 with this jogger. So this jogger here is going around a lake. So we have a lake, right? Here's our lake. And she's traveling around it, right? And I'm assuming she's going to end up at the same spot where she started. So she travels the first half at a constant speed and the second half at a constant speed. So if this is the starting point, we'll say that the first half is about here. But we know the entire distance around the lake, they said, was 5 kilometers. 5 kilometers, right? 5 kilometers equals 5,000 meters. We'll just keep units the same, okay? So we know that she went half that distance. Half of 5,000 is 2,500 meters. So she did that distance at a rate of what? The first time, 5. No, I'm sorry. The first distance constant speed of 4. So she did that at 4 meters per second. And then the second half, which was in the last 2,500 meters, she did that at a speed of 2 meters per second. So those are the facts that we know. So now what's the average speed the jogger did the entire trip? Well, first of all, how long did it take her to do it, right? So to find out how many seconds it took, or is this miles per hour? Yeah, seconds. Okay, so find out how many seconds it took. We could do this. So the first half was 2,500 meters, right? Per nothing, and then we're going to multiply that. We got to get rid of the meters. So the way we do that is that we know this term here is 4 meters per second. Put 4 meters on the bottom. She could do that in 1 second. All right, cancel out the terms. And now we're going to have seconds left there. So now what you do for this is you can figure out my calculator again. And we could do 2,500 divided by 4. So the first half took her 625 seconds, right? That was the first half. So what did the second half take her? Well, we do the same thing. She went 2,500 meters. In that second half, she did it 2 meters per second. 2 meters per 1 second. Cancel out the meters. Okay. And then we're left with 2,500 divided by 2. And she did that part. It took her 1,250 seconds. So the first half, which we'll call A, first half, and the second half, which we'll call B. So this one took 625 seconds. The second part took twice as long. She was going half as fast. That's my seconds. So the total time that she was running was this plus this. So we have 1,250 plus 625. So the total time, T, was 1,875 seconds, right? And in that amount of time, how far did she run? Well, we know that. She ran 5,000. So she ran 5,000 meters in this many seconds, right? So then we just say go to my calculator here, 5,000 divided by 1,875 equals 2.66, repeating, we'll say 2.67 meters per second. That was her average speed. And then it goes on to ask what the velocity was, what the average velocity is. And I don't know if you're talking about vectors. I'm assuming not. So, I mean, it could be like a trick question if you're talking about vectors, because at this time she's going this way, and this way she's going this way, and then she's going this way, and then she's going this way, and then she's going this way. So vector-wise, if you add up all the arrows, it's actually 0. But I don't think that that's what they're trying to do. So what they're probably trying to say is that in certain cases you can say velocity is equal to speed. I think they just want to use the term speed. So if you haven't talked about vectors yet, then the answer to the average velocity, it's going to be the same as the speed. which was, what did I say, 2.67 meters per second. All right, and then draw a position versus time graph of the jogger's entire trip. That would be basically what we just did before, except what it will end up looking like is if you have an x-axis here where this is time, this is distance, right? So at first she's going real fast, right? And then she slows down. So the slope is going to be half of this. So your final thing will look something like this. All right, so that's question 13.